Benjamin Taylor, and this is my SSH presentation. Sorry. Um, so, to get started here, I thought it would be good to just go over OpenSSH, what the SSH protocol is. Um, so, OpenSSH is it's a tool that gets widely used for secure system administration, file transfers, and other remote services. It is going to encrypt the sensitive data like usernames and passwords, and it's used mainly for preventing theft and eavesdropping. The foundation of OpenSSH is based on the free open source version that was developed by, and forgive me if I'm saying this incorrectly, but Tatu Yolonen, I believe is how it's pronounced. At its core, it's going to consist of both the SSH client and server. It utilizes cryptographic keys, which include a user key for authentication and a host key to verify the server's identity. While many configurations are typically done through the command line, there are also graphical user interfaces available for certain SSH clients. Just for those that aren't very comfortable or just don't like using the command line interface. Um, for client configurations, files are located in the .ssh directory and the ssh_config. On the server side, the configurations are going to be located inside of the sshd_config. I could be wrong here, but I'm sorry, I just thought of this. I feel like that D probably stands for daemon, but I could be incorrect in that. But yeah, these settings are going to control how the SSH server operates, including the security features and connection preferences. So getting into some implementation of OpenSSH. So the first step in this process, you're going to need both the OpenSSH client and server packages. Both of these can be done with the sudo apt install command since we're running this on Ubuntu. Before making any changes, it's going to be important, or before making changes to the config file specifically, sorry, it's important that you back up the original that you downloaded. So take, for example, the sshd config file. You can copy this command with the cp command and save it to a different directory. And it's also important to remember that when you do make configuration changes, that you restart the SSH service so that they get applied. Otherwise, they'll never hold. And to also enhance your security, you're going to want to generate the SSH keys. So this is a pretty important feature. You do it by running the ssh-keygen command. And here you can also specify the bit size if need be with the -b option. So once your keys are generated, copy the public key to your remote host using ssh-copy-id, and then specify the username at your remote host. It's important to make sure that your keys are also stored safely somewhere on your device. So set the permissions for it with kmod and to take the necessary steps to make sure that file is not accessible to to unauthorized users. So this is just going to prevent the theft of your SSH keys, and it's going to overall maintain your server's security. So for my first hardening recommendation, I was going to discuss disabling password authentication. So we just discussed SSH keys. This is going to come in a little bit more play here. So essentially the idea here is the only way that somebody is able to access your server is via SSHing with the keys that you generate, as opposed to being able to use passwords, which can be stolen and figured out and and people can try multiple times to use it to figure it out. So you're going to start by uh, SSHing into your server as the root user, and then you're going to create a non-privileged user account with the add user command. And then after this, you'll add them to the sudo group with the user mod dash a capital G option. Once you've done that, you can go and generate your SSH key pair for the new user. So you can run SSH dash keygen, the same command that we talked about in the previous slide. And then you're going to install the public key on the server with SSH dash copy dash ID. And then you're going to use the new username at your server. So once you're logged in as the new user, you're going to navigate to the sshd underscore config file, which is located in the etc ssh directory. And you're going to run the sudo nano command to get into it. And you're going to need to change a few of the lines. So specifically what we're looking at is the challenge response authentication, use PAM, and password authentication lines. So you're going to want to change all of them from yes to no, to turn them off, disable them. And then after that, you're going to need to reload your SSH daemon using system control reload SSHD. So this is going to ensure that your changes take effect, and it's going to disable users from being able to access your server via username and password. They're going to need those SSH keys that we've been discussing. So my second hardening recommendation is going to be to disable the root login. This is pretty straightforward. You don't want people who are remotely accessing your server to be able to have the highest level of privileges. So in order to prevent this, you're going to log into your server with the non-root user. That you can use the non-root user that we created in the last slide. And then you're going to go back into the sshd underscore config file by running sudo nano to get into it. And then locate the line, and that's going to read # permit root logging yes. So for one, you're going to want to uncomment the line by removing the # just to activate it. And then you're going to want to change that yes to a no. And then you're going to want to save the file. And then, as previously noted, you're going to restart the SSH daemon. So you'll run system control restart. And to confirm the changes, you can try and SSH back in as the root user. And this time you should see that there's going to be a message that indicates that permission to that user is denied. And so for my final hardening recommendation, I wanted to go over restricting the command usage. So this is a good way to limit exactly what a user is able to do when they get into your account. So first, what you're going to want to do is navigate to the authorized keys config file, which is typically located inside the .ssh directory for the user. And this file is going to manage hosts and users that connect via SSH, and allows for more specific functions, like auto login is an example of this. And then within the file, you can add a directive for a specific command. So in the case of this file, there's a line that says command equals, and it's going to have the path to a certain command. So it can be something like like ls or cd or whatever. And then it's going to have SSH dash RSA and then, some characters after that. So traditionally, this is going to allow for only a single command to be executed by the user, which, as you can imagine, is pretty limiting. So a workaround for this, a way that you can still limit the options of what a user has without just limiting them to one singular command, is you can set that path to a command to actually be a path to a bash script. So what this is going to do is within the bash script, you'll create a way for users, it'll echo out the options for the user, what they have, and then it'll accept an input, a choice from the user. And after that's that choice has been made, the bash script will execute whatever command is associated with that option. So I have a screenshot here on this next slide that'll go over that a little bit more. But yeah, this is a good way to allow the user to choose from multiple commands, but it'll be all predefined, which means that you'll get to decide specifically what they're able to do without giving them free reins to just do it themselves, which in a way is also good for the it's a bit easier on the user's part because they don't actually have to type out the command themselves. It's just, they're presented with something and they just have to press the button for it. And here's the screenshot. So this is from baildung.com. So as you can see, first it presents the options using the echo command. So the options for the user are to list the directory, ping 8.8.8.8, or the top command. And after that, the bash script is going to read the choice, and then the choice is going to be whatever input the user puts in. So as you can see, the options here are the 1, 2, 3, and then the asterisk is going to be exit. And that's basically the script that's going to run. The user is going to pick between the 3 options, or 4, I guess, if you count the asterisks, and the command will be executed automatically by the program, which is pretty neat. It's a pretty smart workaround to limiting what the user can do. And here's my references. So yeah, thank you for watching.